Greetings, everybody, wherever you may be, and welcome to Kourou, the home of Ariane, for tonight's live broadcast of Arianespace flight number 163. We're coming to you from inside the Jupiter Mission Control Center, where the teams are gearing up for this latest Ariane mission. Commentators Joshua Jampel here with Marianne Leron. And you can follow us on the website, arianespace.com. You can see we're green counting down. We're off again for flight to 163. Good evening to you, Marianne.
Good evening, Joshua, and everybody who is listening to us tonight.
We are coming back to you with a couple days delay with this launch.
Well, the 15th of July, the weather forecast was not good for the opening of the launch window. So we decided to start with a red status on the launch base and wait for the end of the launch window. Everything was fine with the launch vehicle and the satellite up to the very last stage, but at the end the weather conditions remained not good to go, so we did not launch.
Those of you might recall we stopped the countdown at minus 1 minute and 30 seconds. Last night something else, the problem came up with a valve in the cryogenic loading process, so we stopped this process, drained the core stage, the EPC, of its fuel, returned the launcher to safe configuration, and replace the valve, and we're ready to go now. The range operations manager here, you'll be hearing his voice calling out some of the key milestones this evening. Arianespace Flight Directorate, led of course by Chief Executive Officer Jean-Yves Le Gall. Boeing out in California, hello to you, taking the broadcast, good afternoon. Also our friends at Telesat at Ottawa headquarters and at the regional offices across the nation also with us. We hope you'll all stay with us and enjoy what's ahead. The DDO you're going to hear calling out the preparation for the 7-minute mark.
Tour de DDO, attention pour H0 moins 7 minutes. Top, H0 moins 7 minutes.
All right, we're into what we call the synchronized sequence, the final moments of the final countdown.
Yes, also the automatic sequence. During this sequence there is a great number of operations and checkouts are performed to put the launcher in the final conditions before flight. So two systems are operating in parallel, so one for the fluids, parameters like the temperature and the pressure inside the tanks of the cryogenic core stage, and the other one managing the electrical parameters like power technique arming of the launcher or switching the power from ground to the onboard batteries.
So basically the power is passing from the ground and the ground computers over to the launcher, Ariane gradually becoming autonomous in these final moments of the final countdown.
Right.
Over to Alex Madembasi of Arianespace now, who will give us a first outline of this evening's mission. We'll be back.
Tonight's mission is a classical geostationary mission with the satellite ANIK F2. ANIK F2 satellite is one of the heaviest satellites ever launched. The satellite weighs 5,948 kilograms. It's about 7 meters high and all solar panels deployed on a total length of about 48 meters. We have launched to date 4 satellites for Telesat, ANIK E1, ANIK E2, MSAT and ANIK F1 in November 2000. The launcher is a generic Ariane 5 with some improvements and especially for the EPS, which has elongated tanks, extended tanks, and some improvement of the electronic equipment. It is called Ariane 5G+. The mass at liftoff will be about 750 tons, and for a total thrust at liftoff of 980 tons. We use the excess of performance so as to provide to the customer a more energetic orbit. The apogee will be 3,000 kilometers above the standard GTO stationary transfer orbit. This will bring to the satellite more energy, and it will use less propellant to join its final geostationary orbit.
So a big mission, there's Alex on the left, the big mission tonight for a big satellite. The,
Right.
the RCUA, Alex's job is the customer interface with Arianespace.
Yes, the RCUA interfaces with the customer during the final 10 days of the launch campaign. He is also the program director, managing the launch services contract.
Arianespace waiting on the pad.
Yeah, now.
The camera up here at what we call the CDL, this is the launch site, and this team led by the launch site operations manager.
Yes, the COL tonight is Mrs. Christelle Sturbois, the only female COL at Arianespace. So from the CDL, the engineers carry out all the launch operations and checks during the countdown, but also during the launch campaign. So
there are some 900 checks during the final countdown that the launch crew has to verify and validate.
This is why we use computers to do that.
And the computers are located up there where the camera was. The camera now back in Jupiter Mission Control. We're going to go to some shots of the rollout of the launch vehicle. As you can see, she's on the pad now. But on the 14th of July, she came out fully assembled from the final assembly building, also called the BAF, the BAF. Those big doors swing open, as you can see here. And Ariane rolling out on a rail track to the pad.
Right. The rollout operation took place, as you said, on July the 14th, when the launcher was completely assembled in the BAF building, the final assembly building, and ready to go to the launch pad. So it is pulled out by a truck at a very slow speed, around 2 kilometers per hour. And the rollout itself takes 1 hour to go from the BAF to the launch pad. During the rollout, also, the satellite is continuously monitored.
The rollout takes just an hour, but all the preparations last most of the day, because once she gets out there, she has to be hooked up. The telecom systems, the fluids, and the electrics, and all the rest of it. The Ariane vehicle stands a little over 51 meters tall, and she's in 2 parts, or composites. There's a lower composite, which consists of the core stage, which we mentioned earlier, the cryogenic stage, and the 2 boosters. And the upper composite, consisting of the upper stage, called the EPS, with 1 engine, and the satellites.
You can see on the status panel that everything is green for the moment.
Green and go. 1.5 minutes to go before launch. The final countdown milestones, some of the very last ones being checked out by the 2 computers which we talked about. The final control loop check took place at minus 2 minutes and 58 seconds a while ago now. You're going to hear the DDO call out the 1 minute mark in just a moment.
À tour de DDO, attention pour moins 1 minute. Top, moins 1 minute.
DDO's called out the 1 minute mark. We're into the final 60 seconds of Arianespace flight number 163. You can see the website on there. You can follow it on the website. The ignition sequence, the last thing you're going to see is going to be the big engines lighting up, and what happens after that. There are a few things that happen before we leave the pad.
Yes, at minus 6 seconds, the onboard computer takes control of the launch vehicle. At H0, the Vulcan engine, which is the engine of the core stage, is ignited, and the main parameters are checked to verify its functioning. And if everything is fine, 7 seconds later the boosters are igniting, and then we go.
So,
Tour de DDO, attention pour le décompte final.
We'll let the DDO call out the final moments. We'll be back with you after liftoff.
9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage. Décollage.
mighty roar of the big engines on the big Ariane 5 as she lifted off from the pad. You saw all the smoke and the flames billowing out from the core cryogenic stage, which is burning, and the two boosters lighting up the night sky here in Kourou, disappearing for a brief moment in the clouds. Marianne has just returned. You went out on the balcony to watch the launch. You're beaming.
This is absolutely wonderful. I mean, this is unique each time. It's a great moment.
The early flight path, those are the two, you can see the flames there, and we're following by another camera. This is a camera located away from on the islands. The very early flight path is what? We rise up for a few seconds and then tilt.
Yes. There is a vertical ascent phase of about 5 seconds duration. This is the crew of the launch pad, and then the launcher is tilted to be in the correct trajectory plane, and a wall maneuver is performed. This is to maximize the performance and also to have a good telemetry link with the Kourou ground station.
Coming up on 2 minutes, the core stage and the two boosters are burning. The boosters are due to burn out in a few short seconds, and on this brilliant bright picture you'll probably be able to see the flame out and you'll see them separate.
You're very close now to the separation time.
Each booster burning 240, roughly, tons of solid fuel. That looks like the burnout.
This is a real nice picture. You can see the two boosters each side.
And you can see them falling back down into the Atlantic, and Ariane continuing on her way.
Sometimes we do recover the boosters, but tonight no recovery is planned.
So the core stage now, the cryogenic stage, is the only propulsion pushing Ariane. As you can see on the left-hand side of your screen, there's on the upper left, there's the cursor making its way up the line there. There are actually two superimposed lines. One is the actual flight path, and one is the nominal flight path. And as long as the lines are superimposed one on the other, we're doing fine. On the bottom left, some numbers.
You're right. The T is a time in positive time after liftoff in seconds. The A is the altitude of the launch vehicle, so you can see that the altitude is increasing.
Which is normal.
Which is normal, what we want. The V is the velocity of the speed of the launch vehicle. Tonight we will need about 9 kilometers per second.
For the satellite separation.
For the satellite injection and separation.
Well, we're making our way there. We're coming up on 3 kilometers per second. Bob Hladek of
Boeing Satellite System
will be speaking after the launch, along with Roger Tinley and Jean-Yves Le Gall.
C'est excellent.
We didn't hear the DDO call out the fairing separation. Probably the noise of the engine drowning that out. But we've had fairing separation, and we're going to go to a look at the fairing now with an interview with the fairing builders at Controves. Jerome, Controves has always built the fairing for Ariane, hasn't it?
Yes, Controves has built the fairing ever since the beginning of the Ariane program. Controves is a European fairing manufacturer. This is the 163rd fairing that we have built for Ariane, and the 20th for Ariane 5.
You make only one for each launch, but there are different models available. 3, I think.
Yes, there are 3 sizes available. A short fairing of around 12 meters, a medium-sized one, 13 meters tall, and a long version, 17 meters. This is to adapt the launcher to the needs of each different payload. Arianespace, with the customers, give us the specific needs for each fairing, and we produce the one adapted to the Ariane mission.
The fairing protects the payload before and after liftoff, right?
Before liftoff, it protects the satellite from all possible risks from the exterior which could happen here in French Guiana, like rain, pollution or heat. The fairing is air-conditioned inside, and its temperature and cleanliness are closely monitored. After liftoff, it protects the satellite from the noise produced by the Ariane engines. The entire interior is in line with an absorbent layer of foam and helmets cavities, tuned to the frequency of the noise emitted at liftoff.
De mousse et de cavités de helmets qui sont réglées sur la fréquence spécifique du bruit au décollage.
Next, it protects the payload from all aerodynamic effects as it crosses the atmosphere, and from thermal effect due to the heating of the launcher as it passes through the atmosphere at high speed. The outside of the fairing is covered with cork, which insulates the inside from the exterior and this heat.
Qui sert à isoler l'intérieur vis-à-vis de l'extérieur pour l'échauffement.
The fairing is separated after liftoff at an altitude of about 100 kilometers. What's the system used for this separation?
It's a pyrotechnic system. There is a vertical one, which you see here, and a horizontal one. At the right moments, the two systems are activated and cut the fairing in two halves, which separate after a small explosion, and are pushed away from the satellite.
The elements of each fairing are built in Switzerland. How do they get here to Kourou?
All the elements are manufactured in Zurich. Then they are assembled in Lucerne, also in Switzerland. This assembly fairing is placed inside a container and transferred by truck to Basel, where it is put on a barge and travels down the Rhine to Rotterdam. Here it's put on a ship for French Guiana.
And the future of Controverse?
It's linked to the future of Ariane. We will continue to provide a fairing for each launch. We are also beginning development of the fairing for the future Vega launcher, which will also be marketed by Arianespace. We are also participating in other projects. We are working on the ATV, the automatic transfer vehicle, the future cargo ship for the ISS, to be launched next year.
Qui devrait être lancé l'année prochaine.
All is functioning normally on board. In the report, he mentioned there are 3 fairings possible. He didn't say which one we're using tonight.
Tonight we was using a medium-sized fairing type, and we get rid of the fairing when the thermal fluxes or heat frictions are low enough.
In the report, he mentioned the helmets cavities, which are those silver spherical bits designed to dampen the sound waves, sort of like egg cartons. And they're attached to foam which lines the inside of the fairing. Now, this system has been used since the very first Ariane launch in 1979, but it's disappearing with the next launch in October.
Right, Arianespace with CNES developed a new internal acoustic protection of more simple design. It is based on a new form, more efficient. Then we can get rid of these additional helmet cavities. This allows us to save money and to ease the process during the launch preparation. That means save time during the launch campaign.
On the upper left, you see the cursor climbing up the bar. I don't know if you can read it. I think it would say SEP EPC, which would be the separation of the core stage, the first stage. The EPC now finishing its mission, the only propulsion burning. It burns a total of 10 minutes, 160 tons of fuel.
The EPC burns until it reaches a pre-calculated orbit, and then the onboard computer sends a burnout command.
There's a series of 3 commands, actually. I don't know if we'll hear them all, but the first EPC cutoff command is given by the onboard computer, and then 6 seconds later, another order comes to separate the stage. And then 7 seconds after that, a third order comes to ignite the upper stage. So all these orders sent by the onboard computer in that sequence of the stage separation of the 2 composites, the 2 parts of the Ariane launcher. The altitude now, you can see 140 kilometers, fairing separated roughly 100
kilometers, right.
And our speed approaching the magic number of, what was it, 9 something?
9 kilometers per second, about.
Hey, Didier was just called out separation of the core stage. Right on time?
Right on time. So after separation from the upper stage, the onboard computer sent a pyrotechnic order which opens the tank of hydrogen in order to empty it. This is what we call the passivation of the stage. And this is done to avoid any risk of explosion and then debris. Then the stage is tilting to fall down in the Pacific Ocean. because we don't want the stage to stay in orbit.
Falls in the Pacific somewhere near the Galapagos Islands.
Right.
I think after making its way roughly halfway around the planet.
The world.
The first part of the mission accomplished successfully with the boosters burning and the EPC. Second part of the mission now. We can focus on the satellites and the upper stage. And to take us into that, Bernard Puigonier, the mission director. The satellite ANIK F2 arrived in French Guiana at Cayenne's Rochambeau Airport in an Antonov 124 aircraft. It was a very big satellite in a very big container. It arrived on June 8th at the end of the day around 9 p.m. The satellite and, of course, all its accompanying ground segment equipment was then transported to the S5 satellite preparation building, which is now the one we use to prepare satellites. It was a typical Boeing satellite campaign, short and concentrated. The electrical checks took place over 3 days, round the clock. That went very quickly. After that, other functional tests, such as for leakage, were carried out, and these are standard for satellite propulsion systems. Immediately afterward, the satellite was transferred to the fueling area of S5. This part of the building is dedicated to hazardous operations. F2 has over 2 tons of propellant on board, and fueling is always a rather delicate operation. When all these operations had been completed, when the satellite had been put in its flight configuration, it was transferred to the final assembly building, the BAF, where it was hoisted atop the launcher. When this is done, we encapsulate it in the fairing, and the fairing protects it during the atmospheric phase of the flight. Then final checks are carried out on the satellite to make sure all is in order on board for the launch. These are also standard operations, which include charging the batteries and final preparations for the launch countdown. To sum up, it's been a pretty typical campaign for a telecommunications satellite, short and focused as Boeing campaigns always are, or as we say, ship and shoot. Ship and shoot, there's Bernard Puigonier of Arianespace. They shipped and we shot after 12 working days of the campaign for the satellite compared to 34 for the launcher campaign. We're 3 minutes into the upper stage burn, 13 minutes into the mission. We can focus a little bit on the satellites and on this upper stage. What's the role of the upper stage?
Well, the upper stage is used to reach the final orbit, the final stage.
And adjust the satellization of the payloads,
right,
so they can reach their target orbits.
And also to place the satellite in the right position before separation.
Little different role than the earlier stage, than the first stage. A little different speed, a little different propulsion system. We'll get back with a little more on that in just a minute. But for right now, the latest news from Arianespace, and there's a lot of it.
Maneuver.
Arianespace, CNES, and ESA were presented with the Space Achievement Award in Colorado Springs, Colorado, USA on the 29th of March this year. This award acknowledges the work accomplished by the Ariane teams, who launched 182 spacecraft with 116 Ariane 4 launch vehicles for 50 clients worldwide. This award is a tribute paid to the remarkable development work accomplished by CNES and to the entire European industry working under the aegis of ESA. It's also an international recognition of the quality and professional work of the Ariane commercial and operational teams.
On the 8th of May, Jean-Yves Le Gall, Chief Executive Officer of Arianespace, and Silvano Cusini, representing the ELV company, signed a contract which defines the activities to be carried out during the Vega launcher integration and preparation campaigns in Kourou.
On May 10th of this year, during ILA, the Berlin Air Show, Arianespace and EADS Space Transportation signed a contract for production of 30 Ariane 5 launchers in the presence of German Chancellor Gerhard Schröder and the French Minister for Research, François Daubert. This contract, also called the PA batch, will enable Arianespace to ensure seamless launch services and improve once again both its performance and competitiveness on the international market. In addition to the Ariane 5 version, the PA batch will also include Ariane 5 ES launchers for the ATV, the Automatic Transport Vehicle.
Optus has selected Ariane and Soyuz for the launching of Optus D1 and D2 spacecraft from the Arianespace Center. Ariane will put Optus D1 on orbit at the end of 2005. Optus D2 will be the first passenger on the Soyuz launcher, which will take off from the Guyana spaceport in 2007.
Last June 14th, at the Space Industry Forum organized by CASVA in Singapore, Arianespace's chief executive Jean-Yves Le Gall spoke to Asian space industry leaders. He outlined Arianespace's will to provide coherent and compatible launch solutions for its customers' missions, whatever the mass of their satellite.
Jean-Yves Le Gall was present at the Communication 2004 conference, which took place in Singapore last June the 16th. It was here, in front of some 60 journalists, that he reaffirmed the importance of the Asian market for Arianespace.
On July 8th, the French Senate hosted the Future of the Space Adventure Colloquium in Paris. This conference was part of its international meeting series. Attendees included CNES, ESA, SNECMA, ONERA, SES Global, and Arianespace.
Jean-Yves Le Gall was in Sinnamary for the opening of the digital cyberspace on the 10th of July. In 2000, Arianespace signed a partnership with the Guyana Youth Information Center to develop new information and communication technologies. This is the 5th operation of this type sponsored by Arianespace.
All systems are nominal on board, everything running smoothly. And we are in the middle of the upper stage burn, and the upper stage, I wanted to ask you about its propulsion system because it's very different from the lower stage.
Right. The upper stage burned a longer time, around 17 minutes, and burned storable propellant, which is very similar to what is used for the satellite chemical propulsion system. Systems using cryogenic propulsions are more efficient, but also more delicate.
We'll be back after a look on ANIK F2 with Mike Minnis of Telesat. Mike, can you give us a short presentation about Telesat?
Telesat Canada started in 1969 and is in fact was the first commercial communication satellite operator, and since then it has built and operated a number of series of satellites, starting from ANIK A in 1972 to ANIK F1, and now we are on ANIK F2.
The F2 weighs over 5 tons. Now, why so big?
It is bigger because it has more payload, and also because it has the Ka band with its 45 beams, with a lot of frequencies being reused 4 times, in fact, to cover the United States and Canada with the capability of internet communication.
You mentioned the Ka bands as one of the reasons why the satellite is so heavy. Now, this is also one of the big innovations on F2, isn't it?
The ANIK F2 Ka band has quite sophisticated hardware, which is being developed recently, the high-power tubes in that frequency, as well as the receiver and other payload equipment. The reason the Ka band is just now coming into the market is mostly due to the market needs, and also the hardware maturity. It takes time for the hardware and the market to develop before any payload can be put onto a satellite.
This is your first time in S5. How do you find the facilities?
The S5 facilities are absolutely first class. The capability to process the satellite and fuel it without having to transfer it, it cuts out an extra level of handling and the possibility of risk. And the new innovations like the CCU3 also reduces the risk to the hardware before it is transferred onto the top of the vehicle.
Message to your customers now. Imagine I'm the end user of F2. How's it going to change my life?
Especially for our rural customers, it provides the broadband access capability for internet, which otherwise is not available to them. It also provides other rural facilities the Canadian government provides through SchoolNet and through remote medical coverage. ANIK F2 will be a very good addition to what has been achieved so far. It is actually a whole new market for us in the Ka band.
There's Mike Minnis of Telesat. About the G+, now we heard earlier that there were improvements, Ariane 5 being constantly revised and updated.
Yes, for the Ariane system we are always looking for improvements based on flight experience. Tonight the EPS has bigger tanks that allow us to put an additional 300 kilos of propellant. And then the performance is increased by 100 kilos. So speaking of the performance, we optimized tonight the orbit for ANIK F2. The apogee will be near 39,000 kilometers and the inclination of 6.8 degrees instead of the 7 that normally we provide.
So that's good news for the satellite.
That's good news for the satellite. Arianespace always do that to satisfy its customer. So the satellite can save fuel during the travel up to final orbit and increase its lifetime.
We're being picked up by our tracking station, the final one, over in Malindi in Africa in Kenya. Malindi will see the extinction of the EPS and the satellite separations. Station upgraded for the Ariane 5 and is run by the University of Rome. ANIK means?
ANIK means little brother.
Little brother,
in
of course.
Inuit language.
Didio saying that everything is fine on board the satellite. The big ANIK.
The big ANIK is a Boeing 702 satellite bus, a giant of 6 tons mass.
Telesat gearing up for a birthday in September, 35 years. And we have more on ANIK and the group coming up.
Canada's borders stretch from the rocky shores of Newfoundland to the ice cliffs of Nunavut, through our bustling cities and vast prairies, over the Rockies to the shores of British Columbia, a landmass of 10 million square kilometers. The Fathers of Confederation answered that challenge by joining the land and its peoples together with a ribbon of steel, the Canadian National Railway. The railway was the most advanced transportation technology of its time, a technology which, along with early telegraph and telephone service, tied our pioneering peoples together as never before. Today, telecommunications networks and the internet are the new engines of progress, and Canada has a new national dream. A dream of providing all Canadians with access to advanced communication services, no matter where they live. That dream is now a reality with Telesat's ANIK F2, one of the largest, most powerful communication satellites ever built. ANIK F2 is a Boeing 702 series satellite and is the 15th satellite to be launched by Telesat. ANIK F2's principal mission is to replace ANIK E2 and provide enhanced voice, data, and broadcast services across Canada and the United States. In addition to its C and KU band capabilities, the advanced satellite carries a bold new innovation, a state-of-the-art multimedia payload that employs the new Ka frequency band. The Ka band will, for the first time, provide low-cost, two-way satellite delivery of high-speed broadband internet services directly to Canadian homes, no matter how remote their communities. From its fixed orbital position 35,000 kilometers above the equator, ANIK F2 will provide coverage for all of North America, delivering broadband through its 45 spot beams, and allowing people who are currently offline to join the digital world community.
We have ignition.
In 1972, Telesat made history with the launch of ANIK A1, the world's first domestic commercial communications satellite in geostationary orbit. Today, Telesat is a leading consultant, operator, and partner in satellite ventures around the globe. ANIK F2 is the latest step in Telesat's plan to keep Canadians on the cutting edge of satellite communications. It stands at the pinnacle of Canada's telecommunications pyramid, capping a century of progress that has taken us from radio experiments on Signal Hill to a world where children watch and learn from teachers half a continent away. And Telesat's pioneering spirit has helped take us there. Its world-leading expertise in satellite technologies has permitted Canada to fulfill its new national dream: universal access to advanced communication services, which is now within everyone's reach under ANIK F2's far-reaching gaze.
Everything nominal on board. Another 2 minutes roughly for the EPS stage. And while we're waiting for that to happen, we want to give you the quiz question, the moment you've all been waiting for, we know. Quiz question, Arianespace quiz question number 163 tonight. We heard earlier this is the 5th satellite for Canada launched by Ariane. The question, including tonight, what is the total accumulated mass of those 5 satellites launched by Ariane? Once again, the quiz question, number 163, including tonight, F2. What's the total accumulated mass of the 5 satellites for Canada delivered by Ariane? You think you have an idea of what that is?
I think yes.
If you do, don't say it. We'll give you the answer in a minute.
Okay.
But while you're thinking, we want to turn to ZIPS, X-I-P-S.
Yes, on board the satellite there are what we call the ZIPs, in addition to the chemical propulsion system. This is very specific to the Boeing satellite bus. The ZIPs or xenon ion propulsion system are using xenon gas propellant, and to generate the thrust, the ion particles of gas are accelerated through a grid system. This is a very, very low thrust. We talk about the millinewtons. The ZIPs allow to save mass on the satellite bus and to put more payload on board.
So again, good news for the satellites. And while you were explaining all that, we had our call out of the extinction of the upper stage, roughly looking like this. The single engine being ordered to shut down, which means that the propulsion, the powered phases of the flight have now concluded successfully. And what happens now?
Now we are coasting on the transfer orbit. That means that there is no more thrust. The upper stage, the vehicle equipment base, the satellite is now coasting on the transfer orbit, and the attitude control system begins what we call the ballistic phase sequence. That means that a series of maneuvers are performed in order to place the satellite in the desired position before separation.
And that separation due to occur in just about half a minute.
Tonight, the separation system is specific and adapted to the ANIK F2 satellite.
It's a little different than the other separation systems we've seen, huh, with the stages and the fairing?
Right. At the separation plane, you have 4 attachment points instead of the clamp band. And to separate the satellite, the 4 attachment points are cut out pyrotechnically. Then the 4 springs push the satellite away.
And it begins life?
And it begins life, right?
And there you are.
We done it successfully. This is great.
You can hear the applause. Like Minna smiling, beaming. Congratulations all around. Well done for everyone.
This is great.
Now that the satellite has been separated, just to give you a quick idea of the in-flight operations, and then we'll go to a replay from another camera, maybe even 2 replays, so you can live those events again. Satellite will be picked up first acquisition in Nangara. I hope I'm pronouncing that correctly. Sorry if I'm not. In Australia.
In Australia.
It's a Telesat site. The xenon orbit raising that you were speaking about earlier, Marianne, 4 apogee firings on the 6th, 10th, 13th, and 16th orbit. That takes about a month. Here's your replay. The bus testing be finished on the 28th of August. Payload testing take about 3 weeks, finished on the 23rd of September. Here's a replay from another camera now. And relocation to 111.1 West should be finished by the 27th of September, and service ready on the 1st of October. So all the handshaking.
Right. For the launcher side, the passivation phase will start again. That means that the stage will be empty from all remaining propellant. This is to avoid risk of explosion and then debris.
This is a replay from the Toucan site, which is the closest to the launch pad, about 2 miles. We're waiting for the speeches. We're going to hear from Jean-Yves Le Gall and Roger Tinley and Bob Ladek of Boeing. And I can see the gentlemen getting up, and I think they're going to be making their way out here. They're going to be shaking a few hands first inside the fishbowl part of Jupiter. Jupiter's in 2 parts. You can see the technical people inside the fishbowl, and the people from ESA, European Space Agency, French Space Agency, Arianespace, and of course the customers are inside there.
Also
behind
the
them,
CNES, the CNES people,
and the Space Center, and behind them, as you can see, the VIPs and the invited guests. So the technical people making their way out from inside the fishbowl to join us here, and we're setting up our podiums have been set up, and the mics are set up, and as soon as Jean-Yves Le Gall and company make their way out here, we'll have those speeches. A couple of interesting notes on ANIK, now that she's up there. If you go back to ANIK A1, built by Boeing, weighed just under 600 kilos, and 560, I think, had 12 C-band transponders. On F2, which weighs close to 6 tons,
the bigger one,
we are told much bigger. We are told one transponder on F2 has twice the transmitted power of all of A1. So you see the evolution in just, what, 13 years in the satellite business. The deal for ANIK F2 was signed in 2000, and it's the 10th satellite built by Boeing for Telesat.
So we are still waiting.
Still waiting for Jean-Yves Le Gall and Roger Tinley and Bob Ladek to come out. How'd you do on the quiz? You think you got an answer?
Yeah, I can give the answer if you want.
I'll repeat the question. See if anybody in Telesat, maybe even somebody in the press office, would get the answer. The question was, of the five satellites launched for Canada by Ariane, including tonight's, what was the total accumulated mass? Mm-hmm. What did you come up with?
I think it's 26,000 kilos, because I assume 5 tons roughly for each satellite plus 1.
Well, you assume wrong. You're not.
I lose.
You're not. Yeah, you certainly do. You're not too far off. However, here's the figures I have. What did you say? 26 tons.
26,000.
26 tons. I think you're a little
kilos.
high. Here are the figures. Here's Jean-Yves Le Gall is coming up to the podium. We'll give you the answer to the quiz after the speeches. The next voice you hear will be Jean-Yves Le Gall.
Bien, bonsoir. Comme vous l'avez vu, Ariane 5 vient de placer ANIK F2 sur son orbite de transfert
As you've seen,
géostationnaire.
Ariane 5 has successfully placed ANIK F2 on its geostationary transfer orbit. I'd like first to express my thanks to Telesat, who, for the 5th time, has placed its trust and faith in Arianespace. Also, hello to Larry Boisvert, who is back in Ottawa. Thank you very much for your confidence. And hello to Connor. I'd like also to thank the technical teams and crews from ESA, CNES, Space Industries, and Arianespace for the successful launch. And I'd like also to thank the member states of the European Space Agency, and especially France, who have witnessed this evening the concrete realization of their support, which they brought to the European launcher sector. Also, thanks to the teams at the Space Center, who took a few extra days for this success, and we couldn't have done it without them. They worked around the clock. And also to all our partners on the space base, many thanks.
Donc une fois encore, bravo à tous
Once
pour
again,
ce superbe succès.
to everyone, let me say well done
Je passe
for
la
this superb
parole à
mission.
Monsieur
Without further
Roger
ado, I'll hand the
Tinley,
mic
vice-président de Telesat.
to Roger Tinley.
Thank you very much, Jean-Yves. I'm very pleased to thank you on behalf of Telesat Canada for the successful launch of ANIK F2. We had a few trial runs to get here, but all that matters is that we made it. This is our 5th successful Ariane launch. And clearly, Arianespace has played a considerable role in our business. The other ones were E1, E2 in 91, MSAT in 96, and ANIK F1 in 2000. This is also our 15th spacecraft to be launched, and our 10th Boeing satellite, a relationship that goes back to 1972 with ANIK A1. ANIK F2 is a particularly important satellite for Telesat and our customers, including Wild Blue and Star Choice, and I believe the space industry, because it carries a 45-beam spot beam payload, Ka-band payload, which will provide two-way high-speed internet throughout Canada and the US. Success of this launch is the result of technical expertise, dedicated staff, and teamwork between all the parties involved. And by that I mean Arianespace, CNES, ESA, Boeing, and Telesat. We were fortunate to have Bruno Gilles as our range ops manager and Bernard Fugrenier as our mission director for the second time. So thanks to those two individuals. I should also like to mention Alex Madambassi, Denis, Christelle, and Veronique from Arianespace, Bob Laddick, our Boeing program manager, Christina, Jim, and Miguel from Boeing. And from Telesat's launch team, Trevor, Mike, Dan Wang, and Marvin. So clearly, when I mention these names, the success is due to many, many people and all the technical teams, not just a few. And the multiple attempts that have been made have clearly required extraordinary efforts from these people. So in conclusion, we're on our way with ANIK F2. We'll be in operation in early October, and thanks to to Ariane 5. And I think some of us should celebrate tonight this excellent occasion. Thank you very much.
On behalf of the entire Boeing company, I want to congratulate both Telesat and Arianespace on the success of this exciting launch. This is a great day for our entire Boeing Satellite Systems International team. In addition to continuing our long heritage of delivering quality spacecraft to fulfill the needs of the fixed and broadcast satellite industries, we're fortunate to contribute to the introduction of North America's first satellite-based broadband communication system. I would like to thank our hosts, Arianespace, for their wonderful hospitality and cooperation throughout the launch campaign, and for the excellent performance of the Ariane 5 launch vehicle. Thank you very much. It has been our sincere pleasure to work with all of you. And on behalf of all of the people of Boeing Satellite Systems International, as well as our partners and suppliers throughout the world, I want to thank Telesat for allowing us the opportunity to be part of such an exciting program. Thank you very much, Roger. ANIK F2 is very significant to us, not only in terms of the technical firsts and communications capabilities, but also it is a symbol of Boeing's enduring commitment to quality in what we do and in the products we deliver to our customers. We, of course, have more work to do for ANIK F2, so as we continue our work in the weeks ahead to execute the spacecraft transfer orbit mission, deployments, and in-orbit testing, our focus remains on delivering a spacecraft that continues to perform flawlessly. I am very proud of what we as a team have accomplished. It's been a long journey, but definitely one worth taking, and I look forward to the day when ANIK F2 is referred to as the spacecraft that ushered in a new era in satellite-based broadband communications. Thank you very much.
Bien, je vous remercie pour votre attention. Donc, nous sommes dans la deuxième partie de juillet. Donc, je voudrais vous souhaiter de bonnes vacances pour ceux qui en prennent et un bon travail pour ceux qui vont recommencer à travailler, puisque vous le savez, dans les tout prochains jours, nous allons commencer ici la prochaine campagne de lancement pour un lancement au mois d'octobre, et il s'agira, vous le savez, du prochain vol d'Ariane 5 ECA. Voilà, je vous remercie. Bonne soirée.
Jean-Yves Le Gall giving everybody a date in October for the next Ariane launch, and once again, thanking people. We'll go to a final replay of liftoff.
Allumage.
Those stunning shots of the liftoff of the Ariane 5. The answer to the quiz, you had 26 tons. Here are the figures I have. ANIK E2 and E1, 2.9 tons. MSAT, 2.8. Hope you can hear me over the roll of those engines. F1, 4.7, and tonight, 5.9. I have a total of just over 19. That's 19.2 tons. So you were a little heavy.
I was heavy because I overweight the three first satellites.
But not bad. Not bad. If anybody out there got the answer to the quiz question, pour yourself a glass of champagne and celebrate along with everybody here at the Space Center successful launch as Ariane 5 once again delivers its payload, launching ANIK F2 for Telesat, for Boeing, and for Canada. We will say goodbye to you. Thank you, Marianne.
Thank you. I wish us a complete success like that for the next coming launches of Ariane 5.
And
Thank you.
For tonight, the big news, better late than never, and all's well that ends well. The Ariane 5 has, again, successfully delivered her target orbit and target satellite. Thanks for being with us, everybody. We'll see you next time.
Goodbye.